Okay guys, so previously we have learned about congruent triangles, and we have learned all the different ways to prove that triangles were congruent. And in order for triangles to be congruent, they had to be exactly the same, okay? Every piece of the triangle in one triangle would match up with every piece of the other. And there were different ways that we could get these triangles congruent to each other. Okay, so obviously just by looking at my picture, they don't look congruent, but the ways that we could prove triangles were congruent were if we had 3 sets of sides in one triangle congruent to 3 sets of sides in the other, then we could tell that the triangles were congruent, and therefore not only were the sides congruent, but the angles were also congruent. Another way was by side angle side. So if 2 sides were congruent and the included angle of one triangle were the same as the 2 sides and the included angle of the other triangle, angle, side, angle, 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 side, and hypotenuse, leg. So these are the ways that we can identify if these 2 triangles were congruent. And again, once they were congruent, all the sides were congruent to each other by CPCTC, and all the angles were congruent to each other by CPCTC. So first we got the triangles to be congruent. First we proved that they were congruent. Then all the sides were congruent, all 3 sides were congruent, and all 3 angles were congruent. We are now jumping ship, and we are moving to similar triangles. That's 2. Okay, so similar triangles, and it's exactly like what it sounds like. If I told you something was similar, they're alike, but they're not exactly the same. So congruent means exactly the same. Similar means they are alike, but not exactly the same. What we are now going to be working with are triangles that have, and that's not even a triangle, are triangles that were maybe cloned. Oh, my Apple Pen's doing it again, guys. Okay, so we have this triangle right here, and if I was to actually copy and paste it, these are called congruent triangles, right? So they're exactly the same. If I wanted to create similar triangles, I would either have to make this bigger or smaller. So that's what we're going to be dealing with, is we're going to be dealing with some dilated triangles that are similar or that are either larger or smaller, but they should look the same. Like if you look at these 2, you can see that this one is similar to this one. And of course we have to prove that triangles are similar. So we're going to be talking about ways for us to prove triangles are similar, and that comes down here. If you can prove to me that 2 angles in one triangle are congruent to 2 in the other. So I'm going to move this down. Okay, so once again, if you are able to prove to me that this angle is congruent to this angle, and this angle is congruent to this angle, that is enough information to tell me that these triangles are similar. Now I know what you're thinking. If the angles are congruent, how are they similar? But I want you to look at this. Do you guys see how those angles fit into each other? Look at those angles. They fit into each other. Same with these top ones. Look at that. They fit into each other. Okay, these angles still fit. When I make a triangle larger, it doesn't affect the angles. Okay, the angles can't get bigger. The angles are always going to add up to 180. They stay the same. So if you can prove to me that in triangle ABC and triangle DEF, if you can prove to me that angle A is congruent to angle D and angle B is congruent to angle E, then we can then identify that triangle ABC is similar to triangle DEF. And again, you can see that I'm using the symbol for similar. Okay, that is the symbol that we use for similar. Okay, so that is one way of proving triangles are similar to each other, once again. Okay, one way. The next way is by side, side, side. And again, I'm going to, I should have just copied and pasted those. I'm going to draw another set of triangles because we know I'm so good at them. So I'm going to actually take this, I'm going to clone it, and I am going to make it larger. Okay, so I have my 2 triangles. If there exists a correspondence between the vertices such that the ratio of the corresponding sides are equal, this is what it's saying, okay? I'm gonna do this easily. So if, for example, this side is 2, this side is 3, and this side is 4, let's just say that. And then we'll say this side is 4, this side is 6, and this side is 8. Can you guys see that all I did was I took this triangle and I made it 2 times larger? Okay, so if I'm actually identifying or looking at the correspondence between the sides, so if I look at the smallest side here and the smallest side here, and again, I'm going to call this A, B, C, and D, E, F. So you guys can see that if I put A, B over D, E, that ratio is the same as B, C over E, F, which is again the exact same ratio as if I was to say AC over DF. Now notice I put the first triangle, I put all of those sides on top. Okay, so those sides are 2, 3, and 4. I'll use the colors. 2, 3, and 4. Now again, if I put those over the corresponding sides, the smallest side, 4, 6, and 8. If you take a look at all of these ratios, you will find that they are all equal to each other. Okay? They are all equal to each other. They have the same ratio. And if the ratio are equal, I would say that triangle ABC is similar to triangle DEF. And how can I tell? That's by side, side, side similarity. Okay, that's by side, side, side similarity. Okay, so we have angle, angle similarity. If you can prove to me that 2 angles on one triangle are congruent to 2 angles in the other triangle, you know they're similar. Are those triangles exactly the same? No. You can tell one's larger, but they're similar. Okay, are these triangles exactly the same? No. One of them's bigger, but they are similar because of side, side, side. And the last way that we're going to talk about is side, angle, side, and it's exactly as it sounds. If you have 2 triangles, I should have copied and pasted because I'm not a good drawer. That's not bad. If you have 2 triangles and you know that one angle, I'll pick this one. If you know one angle is congruent to one angle, and if you have the sides that are proportionate, so if you know that AB over DE, okay, AB over DE is the same as, now again, I picked the left triangle to go on top. So CB over FE, again, the sides are not equal, the sides are proportionate. And we have angle B equal to angle E. I know that these triangles, triangle ABC is similar to triangle DEF, and that is by side, angle, side similarity. You can clearly see I have an angle that is congruent and sides that are proportionate. If it confuses you because there's no numbers here, let's say, for example, I don't know, this is 3, this is 9, this is 4, then this one is 12. Okay, so obviously I made this triangle 3 times larger. So that's my scale factor for that dilation is 3 times larger. But you can see that those sides, when I fill those numbers in, if I put 3 over 9, that's the same as me putting 4 over 12. If you don't believe me, divide those, you'll get 0.3 repeating and 0.3 repeating. Those are the same fractions, just written in different ways. Okay, so this is side, angle, side similarity. And then I'm going to show you guys a proof here and what this is going to look like. The beautiful thing about proofs, guys, is you only need to find 2 angles that are congruent. Most of the time, angle, angle similarity, I would say 99% of the time, you are going to be using angle, angle similarity because the other ways in proof are really challenging, okay, to do that proof wise. The only thing I would say is we would use side, side, side or side, angle, side proofs more algebraically. In terms of our standard 2-column proofs, we're probably going to be using angle, angle. So let's go ahead and write our first proof of the year. So let's say, for example, we have EX that is parallel to GY, and that is given. I'm going to pause there, and I'm just going to trace this. So EX is parallel to GY. And in my mind, I'm asking, like, why would they tell me that? Why are they trying to tell me that these two lines are parallel? What could I pull from that? Well, if I can find a transversal, and a transversal is something that crosses both of those pink lines, and I can, this is a transversal, I can then identify some corresponding angles that I know that are congruent to each other. So I can identify these orange angles that are congruent to each other because those lines are parallel. So I can say angle, I'm not going to say angle E because I don't know which one you're referring to. So angle DEX is congruent to angle FGY. And again, that's because if lines are parallel, then corresponding angles have to be congruent to each other. Okay, so I've identified those corresponding angles from that given piece of information, and I'm going to write the next given piece of information. So they're telling me that DX is parallel to FY. And again, that's given. And I'm going to come back and I'm going to trace that. I'm going to erase my pink and my green and my pink. And DX right here is parallel with FY. Okay, so again, I'm identifying that I do have the same line as a transversal, and I also have some corresponding angles. I see this angle right here is corresponding with this angle right here. So I'm going to say that angle GFY is congruent to angle EDX. And the reason, again, is the same as my reason for number 2. If parallel lines are cut by transversal, then corresponding angles have to be congruent, right? I can take this angle, I can actually slide it up, it's in the same location, so those corresponding angles are congruent. Do I now have enough information to prove the triangles are similar? Absolutely. I can now say that triangle DEX is similar to triangle FGY, and my reason is because of angle-angle similarity. And that is in step 2 and 4, okay? Again, these are the ways, these are the reasons that you can prove the triangles are similar, and I'm 97% of the time going to be using angle-angle. So you're just looking for 2 sets of angles that are congruent to each other. And this is 8.3.